Hi everyone, welcome to my channel. In this video, I'm going to discuss this Codeforces Div 3 contest. So let us get started. Just a sec. Okay. So basically, the first question was like you could delete the adjacent characters. You are given this string in this problem. Let's say ABCD. The string is given as odd, and you could delete two adjacent characters. So like after deleting like two adjacent characters, you will be left only with a particular only with a single character. So you have to tell like whether this character is equal to the character given as an input, like for example C. So for this string like A B C D E, what you could do, like you will delete these two characters, then C will be left. But if you do it for D, this won't be possible because like you will delete these two characters, you will delete them, so CDE would be left. Now if you will delete CD, then E would be left, and if you delete this DE, then C would be left, right? So you won't be getting this your answer, D as in your answer. So hope I am making sense. So let me explain you again. So what I am saying, let us say um, let us say you are given this string ABCDE, and you have to get this character D at last. So what you will do, you will delete these two characters. Let's say you delete them, so you would be left with CDE, or you delete them BC, so you would be left with ADE, or you delete these CD, then you would be left with ABE. So clearly you are not going to get the answer from this. You could get the answer from this or this. So now from CDE you could delete like CD or DE, so at last you will be left with C or E, both of which are not your answers. Similarly, you would be left with A or E here, so you won't be getting this D as in your answer. So in this case, like for this scenario, this character is not possible to achieve at last. So basically, like what I have done in this problem is, like I could check like if there are even number of characters to the left of the character which I want, like for example D, and even number of characters to the right of it, to the left and right of it, then I would delete those characters and I would be left with only a particular character which I want. So for example, like if you were having this presence of D like this, so now you could make, and let's see this, so now you could, like these are even pair, even number of characters, right? You could delete them adjacently. Similarly, these are even number of characters, so you could delete them adjacently. So this D would be achievable at last. So you just have to do it for every occurrence of D. Like you have to check it, and if for any of the occurrence this thing is possible, like the left characters are even in number and right characters are also in even count, then you would be achieving your character by deleting those two n characters, and that would be your answer. So let me show you the code. So C. So like first I am taking this string S and this character S, character C. Then I am checking for like the particular character if it's equal to C. So then what I will check, the left characters, how many characters are to the left and how many characters are to the right. I'll check both of them are even count or not. If it's even, then I am making this temp as true and breaking out of this loop. If temp is true, then I'll print out this yes, otherwise it's no. So this is what you have to do in this question A. So now let's move forward. Now move to B question. So this was interesting one. Like Little bit of number theory would be required over here to solve it. So in this problem, like, you are given this function, and your a is also given. A is given, it's fixed, and these x can have value from L to R. These L and R are given as an input, and you have to tell the maximum value of this function which is achievable, right? So for like f of 11, where a is 3, like this 5 is achievable, right? So you have to tell for which of the x lying between this range left to R, what would be this maximum value of f of x of, like, it would be now f of a of x, like this. You have to tell this maximum value. So what you could say, what I could say like this, if you are given this L and R and you are given this A, right? So if I get, so what would be this number? This would be the nearest value to R. Nearest value to R, which is divisible by A. Right? I think I'm making sense. Like, this would be the nearest value to R which is divisible by A. This thing, R by A would give me an integer value and I'm multiplying it with the A. So this would be that value. Now you could say, like, if you get here, let's say this was your value Z. This was your value Z. So Z minus 1, let's say. So Z minus 1 by A would be equal to what? Let's say it's not Z. Yeah, this is Z. So Z minus, so let's say Z by A is equal to X. Not X, let it say you are equal to this M. So Z minus 1 by A would be equal to M minus 1. Because this is in floor division. Z is divisible by A. So Z minus 1 won't, like, it would be one number less than M. Then you will be doing this Z minus 1 factorial A. But in case of Z factorial A, it would turn out to be 0. So in case of Z, your f of Z would be equal to M. But here, like, it could be M minus 1 plus Z minus 1 factorial A. And this value could be between 0 to A minus 1. So what I mean to say is, like, if you check for Z minus 1 and Z both, you would get your answer. If you check only for these four numbers, like Z minus 1, Z, R and R minus 1, you would get your answer. Because, like, for the less values, why I would consider this L if I am having a particular value Z, right? But I would need to consider this Z minus 1 as I explained you here. Like, this could exceed this M, this could exceed this M for a particular value of Z minus 1 factorial A. So you need to consider this Z minus 1 and R minus 1 to get your answer. This is what I am doing. Like, I am checking, like, you have to check, like, Z minus 1 should be greater than or equal to left. So first I had calculated this Z, you could ignore this K. And then I had set this my max as the left limit, but you don't need to be, like, very much focusing over here. You need to focus on this thing. Like, for Z minus 1, I check out my maximum. For Z, I have checked out my maximum. For R, I have checked out my maximum. And for R minus 1, I had also checked out my maximum. And I am also checking, like, if my R minus 1 is greater than or equal to left. Then only in that case I'll be updating my max. So this is what I am doing, and like this passed all the test cases. So this was it in this problem. So now let's move to C. It was in kind of implementation problem. The C was very simple and intuitive, and it was kind of an intuition problem. So basically, like you are given these values and you are given these positions here, and you have to create out like 2n pairs, and these 2n pairs are like your these ranges, and you have to map one number to another number in such a way like these ranges don't coincide. Like this should not be the case, right? This should not be the case. Only the allowed cases are like this. So ranges should not coincide with each other. By coincide I mean like they should not intersect each other. Not coincide, they should not intersect each other. They should not intersect each other. So basically, like you have to achieve this, the sum of these ranges should be minimal. So basically, like let us look at the code and I'll explain you there only. So basically, like I have given this like I created this vector of pair. So basically what I am doing, like in the vector I am pushing my this value, let's say 1, 10, 3, 10, and along with the index and this a value like on which it's positioned, and my ith index, because at last like we have to return these indexes. Like 2 to 6 means like this 2 index this 2 minus 2 1 point is marked to 6, like 991. So that's why I'm storing this index I. Then I'm sorting the vector. So now what it will do, it would like arrange your values in the sorted order with their particular positions. Then what I had done, like I had calculated my sum. Now it would be minimal because I am taking this 2n minimum values possible sum. So and after that I created this one more vector and I pushed my this index and this position. By index what I mean, like this is my position, this is my value, and index is the thing which is the order of the segments inserted. That order is there. So like this I plus 1 is this index, A is my position, and B is my value. So basically I sorted them on the basis of the value, so I got the minimum sum. Then I had to make these so I had to make these segments as non-intersecting, right? So what I have done in this case, like I then created this vector of these minimal values, and then I had sorted them again on the basis of this position. So you see like this first is inserted, so I am sorting it on the basis of position now. And what I am doing now, like I am making this first index to map with 2n minus 1 index. So in this way, like, so basically what I mean to say, like, so once your values are sorted basis of the position, so let's say this was your one position, this was for n is equal to 2, for these are your 4n positions. So what I am doing, I am making this length this as in segment and this as in segment. So that's what I am printing over here. So I had printed this, and as I told you, like we have to store this index because we have to return this index, printed this index as an output. So that's what I am doing, like v2i is second and 2n I minus 1. This would be mapping in this way, like for 1 this 2n minus 1, for 2 this 2n minus 2, for 3 this 2n minus 2. So in this way, like I had printed this vector out, and this worked fine and passed all the test cases. So this was an interesting problem. Like, so basically from, like, in this problem I got this intuition from this 10 to the power 3, like I could do it in square complexity. So let me help you understand this problem first. So, like, you could read this long problem. Let us go through the solution or what I have done. So basically, like, you are given this kind of array, and you have to tell, like, whether it's achievable. If it's if this kind of array is achievable, then you have to tell this order of shifts. If it's not, then you have to return -1. So, like, I tried out this combinations, and you could form any of this array. So this -1 is not the case over here. -1 won't be possible, like you will be getting this array at last for every possible permutation. So basically, for solving this problem out, what I started from the back. Like, this 6 I have to, like, before this, since, like, this operation was after the 6, after this, to say, after this 6 operations I am achieving this array, right? And I could see, like, this 6 is not at its position, so it means it's being shifted. It means it's being shifted, right? So, and if I was on the fifth operation, then I could say, like, 6 would be here and rest of the elements would be here. Like, they could be in any order, but your 6 should be here, right? So what I did, like, so your 6 has to be here. So it means, like, your these elements were right shifted. These all elements till here were right shifted. So it means, like, before, this array was looking something like this. These 4 elements were shifted, right? Because if you will right shift them, sorry, because if you will right shift them, then only you would be getting this as your next operation. For n is equal to 6, you would be getting this only. For n is equal to 5, you must have this, because you are allowed to toggle these 5 elements only. So how you would get this array out over here? So I'm moving in the backward direction. Like, for n is equal to 5, you could see, like, shifting these 4 elements would make you achieve this n is equal to 5. Similarly, you will look for n, like, this fifth operation. So here, like, your 5 is on the correct position, so you don't have to do anything. So you would push 0 in this your position. Previously you push 4, because you have to shift 4 times. You shifted these 4 elements to this right side. So you will push 4, and here, like, you check this 5 position is 5 only, which is the required one, so you won't be pushing anything in the vector. So moving further, so n is equal to 4, so your 4 should be here, because for n is equal to 4 operations, you were allowed to toggle only 1 to 3 numbers of 1 to 3 number of this indexes. So your 4 should be here. So this is what I have done. Like, for 4, I'll push these elements here, and then my string would look like this. So basically what I have done, like, I shifted this 1 time only, shifted this 2 time only. So I'll push into the vector this 2. So similarly you will check for this. Here 3, here 3 is here. So you need to push it 1 time. Then you will get this. Similarly for 2 you will push it one time. For 3 it was 1. Similarly for 2 you will make us right cyclic shift only one time. And for n is equal to 1 you have to do nothing, so you'll push 0. And this you would push in the vector, and you would reverse the vector, and you would return it. So basic catch was in this problem was to iterate backward. So this was only required in this problem. So let me show you the code what I have done. Like I'm taking this n, then I'm taking this vector, then I'm finding this current position, which is this function returning this find position. Then I'm checking if my current position is equal to I. If it's equal to I, then I have to don't do anything, then I'll pushing 0 and I'll continuing. If it's not, then what I am doing is like I am pushing my current position into this my v2, because like the current position would be like, since this current position would tell me like these many cyclic shifts have to be done to like move these right elements to the end of this array. So these many operations would be done in this case, and then I've created this new vector. So basically, like, let me show you. So this is your current position, this is your I, this is your 0, and this is your n. So for all these elements from current position to I, so I'll have to move this current position towards here. So what I need to do is, like, first of all I'll be pushing these current position to I elements into my vector, right? Then I'll push then 0 to current position elements, and then I'll push I to n elements. This would be my vector looking. So this is what I am doing here. Like for the current position till I am pushing it into my v3. Then from 0 to current position I am pushing into my v3, and then from I to n I am pushing into my v3, and then I am setting my v is equal to v3. And at last I am reversing this my v2 and returning and printing it, and doing it for the all test cases it would do here. And this function, like, it was v of I is equal to value, so then it would be returning that particular position on which this value is matching to my vector value. And yeah, that was it in this question. So let's discuss about this time complexity. So it would be in order of n, and I'm finding this position in order of n only, so it will be n square. And that's what I have told you before also, like I have watched this constraint and then it got stuck, like it would be done in order of n square only, and in one summation it passed all the test cases. So that was it. And if you have any queries, or like I was unable to make you understand any problem, then you could post that in the comment section. I'll help you through the problem there. Thanks for watching, and kindly subscribe this channel so that it gives me motivation every time to make this kind of videos. Thanks for watching. Bye.